Hi guys, today we're gonna have a look at the rational indices section 3H. First, learning intentions. We gotta understand how a rational index relates to the root of a number. To know how to convert between bases with rational indices and third form. To be able to evaluate some numbers with rational indices without a calculator. And lastly, to be able to apply index laws to expressions involving rational indices. Fractional indices are used in finance, electrical engineering, architecture, carpentry, and for solving packing problems. Volume to the power of 1/3, that is, the cube root, finds the cube's side length and helps find the sphere's radius. The square and cube roots of numbers such as square root of 81 is equal to 9 and cubic root of 64 that it is equal to 4 can be written using fractional powers. Okay, so instead of writing inserts in this kind of radical form, with radical symbols, we could use fractional powers to represent the same number. The following shows that square root of 9 is equal to 9 to the power 1/2, and 3 root 8 is equal to 8 to the power 1/3. Okay, let's understand why. Consider root 9 times root 9. Isn't that 3 times 3, which is 9? And if you convert it to 9 to the 1/2 times 9 to the 1/2 by applying, a to the power m times a to the power n, retain the base at the indices. So we retain 9 and add indices half and half. That's 9 to the power 1. Okay, we don't need to show the 1 because it's just to the power 1. Therefore, you would know root 9 and 9 to the power half, they are equivalent. Also, to a broader context, you could have 3 root 8 times 3 root 8 times 3 root 8 is equal to 2 times 2 times 2 is equal to 8. And that's just 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3 is equal to 8 to the 1/3 plus 1/3 plus 1/3 is equal to 8. Okay, because 1/3 plus 1/3 plus 1/3 is equal to 1. 8 to the power 1 is just equal to 8. Therefore, 3 root 8 is equal to 8 to the power 1/3. A rational index is an index that can be expressed as a fraction. Okay, so what is a rational index? If this index can be expressed as a fraction, then that's a rational index. A to the power 1 of n is going to be nth root of a. Okay, nth root of a. So take a look at these three examples. 3 to the 1/2, that's root 3. As I said before, second root, second root of 3, because we use square root so much time. So we don't show the root 2 here. We just write as root 3, okay? But anything apart from one square root, you gotta show them. So 5 to the power 1/3, that's cubic root of 5, okay? And the 7 to the 1/10, that's 10th root of 7. See that? The bottom is new denominator is always gonna determine the number in here, okay? All right. So this one, in summary, you just need to know a to the power of m over n. That's just going to be, remember this denominator is gonna be this, okay? Be here. It's gonna be located here, and this m is a to the power of m. All right. Okay. In most cases, the index law apply to irrational indices, that is fractional indices, just as they do for indices that are integers. In other words, the index law you've learned before, they are applicable to those fractional indices as well. Okay. All right. Express the following in index form: square root of 11. So that's a hidden 2 here. So that's just like 11 to the power 1/2. Okay, next one. 3x square root of 3x to the power 7. So this entire thing, 3x to the power 7 to the power half. Okay, and we distribute the indices across bases, 3 to the 1/2. x to the power of 7 times 1/2, which is 3 to the 1/2 times x to the power of 7 over 2. All right, now, next one. Okay. Two times 4th root of x to the power of 9. So that's 2. Remember, this 4 is going to be your denominator. So x to the power of 4 on the denominator, and this is your 9, okay? So here we go, 2x to the power of 9 over 4. Next one, 7. If you say square root sign, that's just 7 to the power half. And here, be careful. This is like 7 to the power of 1 times 7. Retain the base and add the indices, 1 plus 1/2, 7 to the power of 3 over 2. Example 2, express the following in third form, okay? If this is on denominator, it's going to be the number, near your radical sign. So 5 here and 3 inside. Next one, again, your denominator is going to be the number near the radical sign, okay? So 5 goes here, and your 2 is going to be here, 5 squared. Example 3, evaluate the following without a calculator. What is 25 to the power of half? All right, we know to the power of half means square root. So square root of 25, which is just 5. And next one, 27 to the power of 1/3. So we have 3 here, right? As I said before, denominator goes near the radical sign at 27 to the power of 1. So what is cubic root of 27? That's just going to be 3, okay? Because 3 times 3 times 3 is equal to 27. Okay, last example, 16 to the power of negative 1/4. Okay, from last section 3F, we know we don't want negative indices. So let's convert it to positive indices first. So you see negative number here. You see negative sign here. We flip it. So it becomes 16 to the power of 1/4. Okay, so that's just 1 to the power. Yeah, this is 4 on the denominator. So that's 4th root of 16 to the power of 1, which you don't where you don't have to show it. So that's just 1 over 2, okay? Because 2 times 2 times 2 times 2 is equal to 4. That's why 4th root of 16, that's why 4th root of 16 is equal to 2. All right, that's the end of today's lesson. Thank you.